Hello, my name is Cecilia Reed, and this is my third lab report for Physics 2212 regarding the relationship between distance and the magnetic field. The purpose of this lab is to observe the relationship between distance and magnetic field. I first went through the lab model to observe the changes in measured magnetic fields, and then fit the experiment to a GlowScript model. Using the Biot-Savart law, I found the distance dependence to be n equals negative 3.34, and the magnetic dipole moment to be 1.65 am squared. The major concepts present in this experiment, which allowed us to calculate the results, were the Biot-Savart law and the distance dependence equation, which we can set together to find mu. To begin the experiment, I downloaded Teslameter to measure the magnetic field on my phone and set up a meter stick outside my dorm. I then placed my phone on the ground and made small adjustments until the number on the phone read 0. I aligned my meter stick with my phone and placed a magnet on the end. I then moved the smartphone perpendicularly to the meter stick and found where the absolute value of x was at a minimum and where the absolute value of y was where the absolute value of x was at a maximum and where the absolute value of y was at a minimum. I marked the location on my phone with a piece of tape. I then rotated my phone 90 degrees and found where the x was at a minimum and where the y was at a maximum, and placed a piece of tape there. I recorded the measurements from my phone at the different locations into the Excel spreadsheet given in the notes. I then recorded 3 measurements from my phone on a meter stick perpendicular to the first. I recorded those measurements at the bottom section of my Excel sheet. For the calculations, I had to assume that the magnitude of the magnetic field was proportional to the constant times the power of the distance. I also had to set up my graph as the natural log of b bar versus the natural log of r, since the regular plot of b would not readily yield the exponent or k. The observations I made during the lab were that the x component increased as the magnetometer on my phone moved closer, and that as my phone moved farther away, the phone measured near 0 in the x direction of the magnetic field. Here's my Excel spreadsheet with the data, including the slope value of n, which came out to be negative 3.34. Next, I performed my calculations using the Biot-Savart equation to solve for k. Since the graph gave me an equation with the natural log of I calculated e to the n to find k. I used the equation from the concepts and set them equal to each other, to make the magnetic dipole, or u, easier to solve. Mu came out to be 1.69 am squared. I used this GlowScript code to model my experiment. I edited the k value to match my calculations and measurements. B was calculated using the equation given to us in the notes. I edited the observation axes to the appropriate vectors using distance. I added arrows to illustrate the magnetic field at different points. Finally, I printed the distance and the b at 45 degrees and the distances. Here's my model, where you can see d and the b at 45 degrees and the distances. You can see my model right here. What if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out our meter stick at some intermediate angle with respect to the magnetic field of Earth? So starting at magnetic Earth ensures that the x component for the magnetic forces is 0t, which means that we measure only the field magnet. If we had not forced the x component to be 0 by starting at magnetic north, Earth's field would have interfered and the x component would not have been 0, throwing off our results. What if 2 identical magnets were stuck end to end? The value of the magnetic field would be almost double what we measured, although the direction of the field would remain the same. It may not be exactly double, though. Thank you for listening to my presentation. I'll see you for Lab 4.